Have you ever just looked at something and thought, yeah, that just looks right? You know, whether it's a huge, impressive building or something as tiny as a snowflake, there's this kind of hidden rule, a secret code that our brains just seem to love. Well, today, we're going to crack that code. We're talking about symmetry. All right, let's just dive right in. Take a look at these two images. On the left, you've got the Taj Mahal. I mean, it's the definition of perfect intentional balance. And on the right, a beautiful but totally chaotic random sky full of clouds. Now, they're both beautiful for sure, but one of them feels designed, you know? It feels like every part has its place. So what's the big difference here? So what is that invisible rule? What's the secret sauce that makes certain patterns feel so harmonious and satisfying to look at? It's a question that artists, mathematicians, and scientists have been fascinated by for, well, forever. And you know what? The answer is actually pretty simple. It's symmetry. It's all about repeating parts in a very specific, ordered way. It's like a visual echo, creating this incredible sense of balance and wholeness. Okay, so let's start with the kind of symmetry we all kind of know intuitively. It's the one that just feels right when we see it. We're talking about the perfect fold, or what's officially known as line symmetry. The definition is actually beautiful in its simplicity. A line of symmetry is just an imaginary line that you could draw through a shape to split it into two perfect, identical, mirror image halves. Probably the easiest way to wrap your head around this is with what I call the paper fold test. Just imagine you've cut a shape out of a piece of paper. If you can find a line anywhere on that shape where you can fold it and the two halves match up exactly, no little bits sticking out, then boom, you've just found a line of symmetry. So let's put this to the test. Think about a simple, perfect square. How many different ways could you fold it so that the two halves line up perfectly? Take a second, really think about it. All right, let's count them up. First, you've got the most obvious one, right? A vertical fold straight down the middle. The left side matches the right side. That's one. Next up, a horizontal fold. Now the top half matches the bottom half perfectly. So that makes two. But are we done? No way, not even close. You can also fold a square diagonally from one corner to the opposite corner. That gives us our third perfect match. And of course, there's the other diagonal, which gives us our fourth and final line of symmetry. So there you have it. A simple little square actually has 4 different lines of symmetry, 4 ways to get that perfect fold. But here's the thing. Folding isn't the only way to be symmetrical. What about all those objects that look really balanced, but you just can't fold them perfectly in half? Well, this brings us to our next big idea, the perfect turn. Just look at a pinwheel. It definitely feels symmetrical, doesn't it? It has that same sense of balance. But if you tried our paper fold test on this, you'd be trying all day. No matter where you fold it, the halves are just not going to line up. This needs a totally different way of thinking. And that new way of thinking is called rotational symmetry. Basically, an object has it if you can spin it around a center point, and at some point before you've made a full 360-degree turn, it looks exactly the same as it did when you started. Let's go back to our old friend, the square. If you put a pin in the center and turn it 90 degrees, a quarter turn, it looks identical. Do it again to 180 degrees. Yep, still looks the same. And again at 270. It actually matches itself 4 different times in one single rotation. So let's just do a quick recap here. Line symmetry is basically a reflection, like a mirror image. The easiest way to think of it is as a flip. Rotational symmetry, on the other hand, is all about movement around a central point. Just think of it as a spin. Okay, so we've got the theory down, right? Flip versus spin. Now let's see how these concepts actually work out in the real world, and maybe even try making some symmetry of our own. Turns out, some of the most amazing shapes out there actually combine both types of symmetry. We already saw the square does. But look at a flower. This one has 6 lines you could fold it on, and it looks the same at 6 different points when you spin it. And then you have something like a cock snowflake, which shows how a simple rule can create these infinitely complex and beautiful symmetrical patterns. It's amazing! And hey, you can be an artist of symmetry too. Remember doing those ink blot paintings when you were a kid? Well, that's a perfect hands-on demonstration of line symmetry. The fold in the paper literally is the line of symmetry, and whatever crazy random shape you make with the ink on one side gets perfectly mirrored on the other. That simple ink blot really shows how natural this concept is to us, and once you really get the basics of line and rotational symmetry, you'll start seeing them absolutely everywhere. It's like you've been given a new lens to look at the world with, from art and culture to nature and design. For instance, take the Ashoka chakra. It's a really powerful cultural symbol, and you can see right away there are no simple fold lines here. Its beauty and its power come from those 24 spokes, which create this perfect, undeniable rotational symmetry. Now, how about this? Look at this drawing of the Parliament building. Your brain immediately gets that sense of balance. Can you see it? Can you mentally draw that line of symmetry right down the center? That's reflectional symmetry, or line symmetry, being used to create a feeling of stability, power, and grandeur. So we've seen how symmetry is this hidden rule, this code behind so much of what we find orderly and beautiful. It's like a formula for perfection, which of course leaves us with one last really interesting question. If symmetry is the rule for beauty, what happens when you break it? What's the power of asymmetry? Now that's something to think about.